Okay, for the flow rate calculation, let me give you one more examples. This is example 5.3 in the textbook. Okay, please read the textbook also. There are more examples in the textbook, 5.1, 5.2, 5.3. Okay, before you do the homework, it will be good to read the book. Okay, this is 5.3. The problem is, this is a open surface flow. It's like a river. Okay, bottom is the wall, the seabed. Okay, the flow is from left to right. Okay, it's not a constant flow, right? The bottom has zero velocity. In the top surface, you have the maximum velocity, U max. Okay, so the velocity distribution is a function. The velocity U change with y. Okay, it's U max times y over d square root. Okay, so that's the function of U. So you change with y. Okay, flow is from left to right. Okay, the problem is to ask you to calculate the flow rate. Okay, so the value is given, U max equal to 3 meter per second, D is 2 meter, and the width of the channel is 5 meter. So it's 3D, right? X is flow direction, vertical is Y direction, then Z direction is going out of the paper. So the width is in the Z direction. Okay. Obviously, in this problem, you're going to use non-uniform flow rate calculation. So the flow rate should be equal to U times dA, then take integration. Okay, so how do we construct the dA? That's a problem, right? Okay, so let's have a front view. We look at from the front. From the side, from the left. Okay, so we are looking at the YZ plane. So this is the YZ plane, right? This is the cross section the flow goes through, right? This is a cross section. So we need to define the dA. Okay, the entire area is 2 meter by 5 meter. Okay, it's a cross section of the flow. So this is how the dA is defined in this particular problem. Okay, so the expression for dA is the width of the channel, which is 5 meter, times the height of the bend, which is dy, right? Y direction, y and z. So dA equal to 5 dy. So this is the calculation. So Q equal to U dA. So equal to the expression of the U, which is U max times the square root of y over d, times dA, which is 5 dy. The limit of dy of y is from 0 to 2. Okay. So U max and the D are all given. So you can move it out of the integration. So you take integration of the square root of y become 2/3 y to the order of 3 over 2. Okay. The limit is 0 to 2. So you can calculate the flow rate equals 20 cubic meter per second. Okay, so this is how we calculate. One example to show you how to calculate the flow rate for the non-uniform flow. So please practice with your homework problem on this topic. It's very important because for the conservation of mass, it's very important to calculate the flow rates.